So let's move to a next step. In step one, we took how we can find the atomic mass from the periodic table. So we checked for iron in the periodic table, and we found that its atomic mass is 55.85 AMU. AMU means that it is the atomic mass unit. It is per one atom only. But if we want to know the mass of 1 mole of, this is for one atom, atomic mass unit 55.8, and for 1 mole, 55.85, but this time not in atomic mass unit, this will be in grams. So 1 mole of iron atoms weigh 55.85 grams. If we want to move to step 2, we want to make a compound now. Like if I have FeCl₃ and I need to know what is the mass of 1 mole of this compound. This is an ionic compound, so we calculate its formula mass. If you don't know what's the formula mass, please watch video number 1. And molar mass is, so I have Fe one atom only. The mole of iron is 55.85 grams. And for Cl, it is 35.45, but this is multiplied by 3. So it is 106.35. So for iron, it is 55.85. For chlorine, it is 3 atoms, 106.35. All I need to do is add these two together to get 162.20 grams per every mole of the iron. So this is just not one atom of iron, it is a compound, and the basic structure is FeCl₃. This is not 4 atoms only, there is a mole. So there is 1 mole of this one, 1 mole of this one, 1 mole of this one, 1 mole of this one. The mass of 1 mole of this one is 55.85. The mass of this is 35.45 times 3, and then we add this all together to get our answer. Now, let's try to see what happens if I have a molecule. And the difference is this is not an ionic compound now. This is a covalent compound. So water is a molecular compound. But the calculation method is exactly the same. I have a water molecule that's made from 2 oxygen atoms, 2 hydrogen atoms, and 1 oxygen, that's H2O. The mass of 1 mole of this one is 1.008. This is for 1 mole of hydrogen. I have 2 of these, so I will multiply this by 2, and then I will get the answer as 2.016. And for the oxygen, I have 16, and I will multiply this by 1 because I have 1 only. So this is for oxygen. So the total will be 16.00. And when I add these two together, I get 18.028 grams for every mole of water. The molecule of water has an 18.02 AMU. This is per 1 molecule. And the mole of H2O molecules is 18.02 grams. This is per 1 mole of water molecules. That's 6.02 times 10 to the power of 23 molecules. So as a summary, if you have single atom only, you are going to use the periodic table, find the atomic mass or the molar mass. The compound, by the way, atomic mass if you are talking about 1 atom only, and molar mass if you are talking about 1 mole, but the number will be the same. It is the same number. So if you have hydrogen or oxygen now that we talked about, it is 16 for every atom, 16 atomic mass unit for one single tiny atom, but for 6 trillion atoms, that's 6.02 times 10 to the power of 23. That's 1 mole of oxygen atoms. That's too much. It will weigh also 16, but this time it will be 16 grams. What about in the case of a compound? You just add the atomic masses together. Formula mass if it is ionic compound and molecular mass. This is only the difference in the name, but the calculation is the same by the addition. Scale up, multiply by the number of moles and total mass of the particle count. Now we're going to do something nice is that we will answer a real past paper question about what we have finished until now. This is question 13 from the AP Chemistry exam 2018, the free response questions. He's saying that a student is given a sample of powdered Fe. So the iron contains an inert impurity. Don't worry about that now. The student uses a procedure to oxidize the iron to Fe₂O₃. The student collects the following data during the experiment. The mass of Fe with the inert impurity is 6.724, and this is the number we are interested in now, 6.724 grams. Calculate the number of moles of Fe in the Fe₂O₃ produced. So in order to find the number of moles, we need to find what is the mass of that. So the mass is 6.724, and you said that for every 1 mole of the iron, the mass is 55 wait, what was that in the periodic table? 55.85. So the molar mass or the mass of 1 mole of Fe is 55.85 grams. And you are not looking for the Fe alone, you are looking for the Fe₂O₃ number of moles. So the mass of 1 mole of Fe₂O₃ is found like we did before. We multiplied the 55.85 multiplied by 2, and the oxygen 16 multiplied by 3. The mass of this one is 111.70. And the mass of this one is 48. And when you add these two together, you get 159.70. So the mass of 1 mole only of Fe₂O₃ is equal to 159.70 grams for every mole. So he's asking how many moles. How many moles do you have if you have this mass, 6.724? No, this is only for iron. So this is the mass that we want, 7.531 grams. So all you need to do is do a cross multiplication. So 7.531 multiplied by 1 divided by 159.70. That's equivalent to 0.04715 moles of Fe₂O₃. This is very good because it's going to help us a lot in order to find the number of moles of substances, and we can actually make a rule out of that. The rule that we are going to do says clearly that every time you want to find the number of moles and you have the mass and you have the molar mass, you are going to use this triangle because it's going to help you a lot. What does the triangle say? It says that the number of moles that we were looking for will be found out by dividing the mass that we had, the mass in grams, divided by the molar mass. So divide this mass by the molar mass, which we found out by addition to get the number of moles. This is exactly what we did. What did we do? We divided the mass, which is 7.531, this one, divided by the molar mass that we found by the addition, which is 159.70. So we got the number of moles, which is number of moles of Fe₂O₃, that's 0.04715. Remember that you can find a lot of past paper questions which are specific for this unit and this topic in our file. And as usual, I will leave you the link for this one inside the video description. Contains only questions from Unit 1 arranged, and there is an answer file also, detailed answer file to show you how you can answer all the questions of actual exams in the past. The last step, by the way, which I haven't taken until now, but I will be solving. If you found the moles of Fe₂O₃, you can find the number of moles of Fe as well. This will happen by knowing the reaction stoichiometry. So we know that the number of moles of Fe₂O₃ we found using the molar mass. So we said that the number of moles is 0.04751. So we write it down here, 0.04715. And he's asking to find the number of moles of Fe inside that. We know that every mole of Fe₂O₃ contains 2 moles of Fe. Do you remember the calcium chloride example in video number 2? So and contains 3 oxygens. So all you have to do is multiply this number by 2. All you have to do is multiply this number by 2 to get the number of moles of Fe inside the Fe₂O₃. So let's do this by the calculator. This is going to get us 0.04715 multiplied by 2. It is 0.0. So it's going to get us 0.0943 moles of Fe.